for our first video question, the question is, if f of x equals e to the x and g of x equals square root x take 3, find whether f of g of x and g of f of x exist. For any composite functions that do exist, state the rule and the domain. Now I've written these two functions over the page and I need to look at their domain and range. So the domain and the range of functions f and g. And I'll put it in a little table like this. Picture the graph of this. The domain is R and the range is from 0 to infinity, not including the 0. Now you're expected to remember the types of graphs that you learned last trimester. For g of x, it's a square root x graph, translated 3 units to the right. So the domain is 3 to infinity, and the range is 0 to infinity. Now we were firstly asked, does f of g of x exist? If it does, the range of g is a subset of the domain of f. Now, is this true or false? The range of g is a subset of the domain of f. That's true. So I'll leave that symbol as it is. It is a subset of the domain of f. Therefore, f of g of x exists. Now I need to state the rule and I need to state the domain. F of g of x, so we're subbing g into f, is e to the power of square root x take 3. And I think I'll put the domain over the page. So, the domain of f of g of x is equal to the domain of just this function. And that was from 3 to infinity. Now we need to find whether the other composite function exists, which is g of f of x. Does this also exist? If it does, the range of f will be a subset of the domain of g. The range of f will be a subset of the domain of g. And that's not the case this time. This is a wider interval of values than this is. So the answer is no, that doesn't exist. So firstly, it's not a subset, and I simply make that change by saying it's not a subset on the symbol. Therefore, g of f of x does not exist. And that's the type of working that you need to show for a question like that.